Greetings everybody. Today we are going to talk about our data segregation algorithm project. For this project, we were supposed to take a real world problem. So we have choose the friend recommendation system in social media apps as our problem statement. Talking about our team, we have Ashwin 2022, Yajat 2024, me 2027 and Jessica 2043 on our team. Now, going further with the introduction of our project, Jessica will continue from here.
The abstract is about social link. Social link is a friend recommendation system that employs graph algorithms to provide personalized suggestions in social networks. It analyzes social connection, including mutual friends, interests, and behavior, while ensuring efficient data access using hash tables for quick user profile retrieval. This approach enhances user engagement and fosters network growth. About the introduction, in today's social media driven world, connecting with relevant people is crucial. Social link aims to elevate the social networking experiences by utilizing advanced graph algorithms, network experience by utilizing advanced graph algorithm for deeper user connection, personalized friend recommendation, accounting for mutual connection, interests, and behavior, enhance user engagement, efficient data access through hash tables, streamlined connections, fostering network growth. Talking about their objectives, the objective of the social link, social network friend recommendation system project are enhance user engagement and facilitate network growth by providing personalized friend recommendation. This is achieved through efficient data access and comprehensive graph based analysis, ensuring users connect with relevant individuals based on mutual connections, interest, and behavior, ultimately enriching the user experience and expanding network. So the problem statement highlight inadequate friends recommendation on social network leading to user dissatisfaction and hindering network growth. Users frequently encounter irrelevant friend suggestions resulting in a subpar experience. Addressing these issues is crucial to enhance user engagement and foster network expansions. So the solution for this is the first solution is title graph based friend recommendation algorithm, emphasizing its focus on in depth network analysis and personalized friend suggestion. The second solution is efficient hashing for data access and friendship status check.
So this was the introduction of our problem statement. Now going to the solutions, Yajat will start with the first solution.
Now coming to the solution one for this, we have graph-based friend recommendation algorithm. This involves firstly graph-based model, common neighbors algorithm, context-aware, efficiency, comprehensive understanding. Coming to the second slide, it talks about the algorithm which we use to solve the code, like implementation of graph, common neighbors calculation, mutual friend sorting, contextual analysis, recommendation generation. Now coming to the third slide, we have just made a flowchart. First we start the flowchart. After that, create graph, and then identify user, find mutual friends. Sort by mutual friends, contextual analysis, recommend friends, and then we end this flowchart. So the fourth slide is about the pseudocode, which we used in this code for building this code. So these are the codes we use. Like graph is equals to create empty. Just go through this, and you'll find that what we will use in this. Now coming to the time complexity, first in initialization, we take 0 of 1. For population, we of get O of E. User selection, we take O of 1. Recommendation generation, we take O of F square. And for the last, the display, we use 0 O of R. Now, coming to the space complexity, firstly, graph data structure. Secondly, recommendation storage. Thirdly, auxiliary data structures. Fourth, user profile data. And fifth is space complexity. Now, the last slide is about the visual representation. So here, user one is friend of user two, and it will be connected to user three, and there will be a recommendation where they can make mutual friends and so on, and they will make different user friends to different one, and this is the only thing we have done in this. So we'll conclude this that, and thank you.
So this was the deep introduction of our first solution. Now for the second solution, Ashwin will take over from here now.
Hello everyone. So my topic is efficient hashing for data access and friendship statistics. The second solution relies on hash tables for efficient storage and access of user profiles and relationships, ensuring quick data retrieval and facilitating instant friendship statistics. The algorithm for second solution centers around hash table initialization where user profiles and friendships are stored for quick access. Users' unique IDs serve as keys, providing efficient data retrieval and instant friendship statistics. The provided chart illustrates a flowchart for the second solution, which relies on hashing. It starts with start and proceeds to initialize a hash table, populate user profiles, retrieve user data, check friendship status, generate friend recommendation, and conclude with end. The concise pseudocode outlines the central steps of the second solution, which utilizes hashing for friend recommendations. It starts by initializing a hash table, populating it with user profiles and features, selecting a target user, generating friend recommendations based on the hash table, and finally displaying these recommendations to the target user. The time complexity for the second solution can be summarized in 5 key points. Initialization is a constant time operation, while population of the hash table scales with the number of users in. Target user selection is efficient with constant time complexity. Recommendation generation takes time linearly proportional to the user preference set. And displaying recommendation scales with linearly with the number of recommendations are. The second solution, space complexity, is concisely summarized in 5 key points. The primary contributor is the hash table, which scales with the number of users n. Additional space is allocated for storing recommendations. The provided chart visually represents the second solution that utilizes hashing for friend recommendations in a social network. User profiles are stored in a hash table where user IDs serve as keys. Thank you.
So this was the deep introduction of our second solution. Now we will see a brief about both the solutions and decide which is the best solution for our problem statement. Talking about the first solution, the graph-based solution offers advantages for complex network structure, enabling in-depth analysis and context-aware friend recommendations. However, it can introduce higher space-time complexity, particularly in large networks, and may be more challenging to implement due to its intricacy. For the second solution, the hashing-based solution excels in efficient data access and rapid friendship statistics, making it ideal for systems with a substantial user base while remaining straightforward to implement. However, it may not be the best choice for complex recommendation algorithms that rely on network structure and user behavior, where graph-based solutions are more suitable. Now, the best solution would be the graph-based solution because it is often preferred for social network friend recommendation due to several key reasons. It excels in network analysis, enabling a comprehensive understanding of the social structure, the context-aware recommendation that consider interaction, and the implementation of complex algorithms. Graphs also offer better scalability as networks grow and they provide a natural representation of social connections. In contrast, hashing, while efficient for certain tasks, may not match the depth and capabilities of the graph-based approach, making it a stronger choice for this application. In conclusion, the choice between the friend recommendation solutions should be flexible and tailored to the specific needs of the social network. Graph-based solutions offer depth and context-aware recommendation, while hashing-based solutions excel in efficiency. A hybrid approach can be advantageous in certain scenarios, optimizing both network analysis and data access. Ultimately, the selection should align closely with the project's unique requirement and priorities, ensuring the chosen align with the project's goal. These are the reference for our problem statement. So, this was our data succession algorithm project. Thank you very much.